Thank you for the survey today. Please note that the footage could be out of position, out of alignment. Sorry about that. I've just put it together in rough format. What I'm going to do is pull together pieces, add it to surveys from other properties so you can see your property in the context of other properties, and likewise the data loggers. Please send me the data not this coming weekend but next weekend, and I will then pull them all together. Note that some of the conclusions evolve as the survey goes along. Have a listen to the survey now. You've got mould as you have here.
Yeah.
It's primarily caused by excess vapour, made worse by heat loss, heat differential, thermal bridging, and so I'll have a look from both angles, and
Yeah.
it's all solvable.
Sure. And there's access to, like I said, there's access to the loft. Yeah.
Through there, yeah. Okay.
Through there.
Yeah.
If you want me to bring the ladder down, I can bring it down for you.
Yeah, why not? So where you've got the greatest mould is where you're getting the greatest heat loss. And it's going down to, what are we? 14 degrees centigrade. And we'll have a look at the data loggers now. Oh yeah. So where you've got the greatest mould is where you're getting the greatest heat loss. And it's going down to, what are we? 14 degrees centigrade. And we'll have a look at the data loggers now. So the dew point is 12.4. This is adjusting. It takes about half an hour to adjust fully, but what we're seeing is that the cold area here was about 14, and that's within 2 degrees centigrade. That means that the surface relative humidity is going to be about 90% at the time of the survey, and mould grows where the surface relative humidity goes above 85%. So let's just have a look. There's a passive vent, but you won't get any benefit from that because it's in a cupboard. We actually need to block it. You can see that there's condensation dribble marks. So this property has been insulated. It's got cavity walls. It's a 1950s property. So this is using a damp meter. You have to put it on masonry mode, and it's actually dry there and there. This will be to do with insulation imbalance, and we'll look in the loft. There's actually quite a lot of mould in the loft as well. Let's have a look, see what we can find. Here we go. So the zone that we were looking at is over there, and it's close to the pitch of the roof. External, you can see there's the patches of missing insulation such as there, and it's that imbalance that's increasing the risk, but the primary cause is the vapour, so we're going to have a look at that now. So the nearest wet room to the master bedroom is this bathroom, and well, we can see there's lots of vapour. It feels very humid. There's an extractor fan there. The door was left open, and it should be closed at least until the room is dry. So I'm going to test the extractor fan, see how well it's working. You can actually see condensation in the bathroom. I'm not sure whether this is highlighted, but that's condensation. So this is an anemometer, and this will tell us speed of the fan. So that lower number, the 5.6 litres a second, 5.8, maybe 6, should be 15, and it's not going as fast. So we'll have a look to see and understand why that is. There's an isolator switch. When we turn that off, it turns the fan off. And we can, initially we can just take the blades off, pull them out and have a look to see what the problem is. Pulling the blades out, we see that there's big dust build up, and that will slow the fan speed considerably. But every fan's different. This one has a couple of screws here, so I'll loosen those. The blades aren't coming out easily, so don't push it. So we can see there's a backflow shutter. I think the main problem is just dust, and you can actually just put your fingers in like this and pull out the dust. That can speed it up dramatically. So that's more or less doubled the speed, just clearing the blades of dust. This number means something, I'm not quite sure what it is. That may be the through flow. It's upside down, I think. I don't know. It's worth looking it up. So this is with a cover on. It's 7.2, so better than it was, but not as good without the cover, but that's not much choice. You'll notice a lot of dampness around the system because the water comes in at temperature that's similar to the outside. So if you look at the condensation on this, it's greater because of the heat loss. The fan is turned off. As soon as I turn the light off, it should remain on. Best thing to do is just keep the light on for at least half an hour. There are three things that are influencing this wall here. So you've got the excess vapor, that's the primary cause. The secondary cause is heat loss. So in a lintel like this, you're bound to have metal, and the metal gets cold quickly. You may have some cracks on the outside, and we're going to look at that, but I'm not seeing brown staining, which is the normal sign of penetrating damp. Then the third thing is the airflow is reduced by curtains, which obviously you need to have, but it's just a factor. Also into the recess, into the window reveal, as it's called here. So that slows the airflow from the radiator. You're drying clothes on the radiator, which obviously is producing extra vapor as well. So now we're seeing the dew point is 13.7. So this wall is a similar temperature to the dew point, which is why you get condensation and mold. We'll take it outside later on and show you what it is outside. Well, I'm sure, I know. So there's the underfloor heating. It's nice, but drying clothes internally, we're going to have to do something about that. I'm going to your bedroom now. This is an infrared camera. And now we're looking at the huge heat difference. So that's showing 15 degrees centigrade. It's we're looking at the mold.
Here.
Yes.
This side.
There as well. Okay. And that's actually 16 down there. It goes down to 13.2, and over here
Small, yeah, that's good.
is 15, 16.
Actually, since I have humidifier, you know.
You got a dehumidifier?
Yeah.
Whereabouts?
I keep it down as much as I can.
You got a it's relatively small though, that one. It's good,
But
but it's
on
on
all
the
day.
small side.
No, but it's on all day, you know.
No, but the capacity is not as good. The fan seems to be mainly going up. There's a bit of a leak here. You can see all the air coming through. And you can actually see some condensation dribble marks down. But that's less important. The main thing is to use it. I don't know, but I'm guessing that the extractor fan for the kitchen goes up into the chimney stack and out, because I don't see any external vents or ducts, outlets. I think the kitchen fan works reasonably well, but I can't tell where the outlet is, but it doesn't appear to be recycling back into the property, other than a certain amount from there. Enclosed internally, particularly with a heated dryer, needs to be compensated for with a dehumidifier, and your mother-in-law has a dehumidifier, but it's not strong enough. I'll have a look at that. It says it's 12 litres per day, but it should be 20 litres a day to cope with the amount of vapour that's generated. I would say you're going to have at least one, if not two, dehumidifiers to cope with the amount of vapour that's been generated here. So we're on the outside. We're looking at so these render cracks can cause water to pass through into the cavity. It's difficult to tell whether it's getting through. They look very fine, but the thing is, a thin crack can draw in a lot of water through capillary action, and you can see that there is moss growing on it, so it's clearly some water in there. But if not, what it can do is just dampen the outside brick. We can see with these dots here that there's been cavity wall insulation, so generally that isn't a problem, but if water gets through the render, then it will dampen the cavity wall insulation, which will actually be counterproductive. But I'm not seeing dampness and mould on this side of the property. It's on the front, and actually the front is south facing, I believe. Oh no, sorry, the front is north facing. So that's why it's colder. That's true. No, the front is south facing. The front is south facing. Okay, these should be dealt with. And cracks there. These and these ones here. I mean, any one of them can be letting water in, but I don't see brown staining on the inside, suggesting that it isn't penetrating all the way through. We're going to study this on the computer. Have a look in. That's where there's a lot of damp and mould above the windowsill, but it doesn't appear to be penetrating through. That's the roof. The roof looks in reasonable condition, really. Some dilapidation there, but that's not where there's dampness. Some degrading of the render, and that will cause a thermal loss, thermal bridging as it's known. So this render appears to be impermeable. It may have a coating on top. Certainly it's been repainted here, so this will have been patched up and repainted at some stage. There's obviously paint on there. But as a general rule, if you've got impermeable render, you need impermeable paint. Otherwise you can just hide a crack and the water still be absorbed inside. It can cause increased dampness on the inside and therefore increase mould, but as a general rule, if you've got mould all over the place, then that's excess vapour is your primary issue. So you're getting mould in here as well, and that's because in the porch it's essentially unheated. Every time the front door's open, the vapour will get in, and yeah, so that increases the risk of mould. Mould grows where relative humidity goes above 85% for long periods of time. So you're getting the vapour from inside, but it goes cold. Relative humidity is a measure of air's capacity to hold moisture. The warmer it is, the more moisture you can hold. Conversely, the colder it is, the less you can hold. until you get to a point where it can't hold anymore, and that's called the dew point. That's where it's 100% relative humidity. So it's a function of both the amount of vapor in air and the temperature. So to set up the data loggers, you want to go to an app called SensorBlue. So I've already got it on this phone. And you want to add the data loggers and pair it. The two here. Done, and pair it again. And then so they're the data loggers, and what we want to do is just calibrate them. So if we go down, so one of them is, so it's showing 63.9 and 62.2, and I've got 64. So we'll just, you see that it's changing. So this one is pretty accurate. 12.5 the dew point. So you can see this more or less halfway between the two there. But if I find it and then locate which one is which, and I'll give it the name. So this is the master bedroom. So name it master bedroom, master, and then I normally add the postcode, and then I'm going to just calibrate it. So I'm going to just take a little bit off that, 0.2. minus 0.2. It's not picking up 0.2. There we go. You'll see that it varies quite a lot constantly, but for that moment it's correct. But don't worry too much about it. It's 1.6. So that is now, the master is showing more or less the same as that, but well, you get constant variation, so don't worry too much. And this one is grandma's room. And calibration. We're going to add 1% relative humidity, 1.54, 44, and minus 2.9. There you go. So dew point, they're closer, but there's just constant variation. The window's open, which is great, but the airflow is just going to change. Oh look, it's 12.2, 12. Well. So to collect the data, just press the green number. It takes about a minute per week. So it's using Bluetooth. The data is held on the data logger, and then I'll get you to send it. You'll press the calculator sign top right and the export sign top right, and then either open, or often quicker is to press the export CSV, but it doesn't always work. So very little air is coming out of this one as well. We'll turn it off and have a look, see what's happening here. So far, there are three things that have come out really. Yeah. So you've got high relative humidity, a high dew point. So internally you want to keep the dew point below the outside temperature, and it's relatively high at the moment. So that's number one. Number two, and so that's caused by excess vapor being generated in the property. So I can see immediately two issues that need to be addressed. One is the extractor fans aren't working very well. So it should be running at 15 litres a second. This one's running at 3, and the one upstairs was a bit faster. I've improved the speed of the one upstairs. Okay. But there may be some sort of adjustment on this one. I'm not familiar.
Yeah. This one, I just bought this one recently, so I can find the paperwork.
So often what they do is they set them up on the lowest setting because they sell them on the basis of it being quiet. But obviously the speed the noise and speed are sort of go disproportionate.
Okay.
So you want to have it at 15 litres a second. The one upstairs doesn't remain on when the lights are switched off.
Yeah, I'm good. So it's one of the things I want to get an electrician to come in so it can
Okay.
come on and off when the humidity.
Well, the other,
Yes,
but you can do it manually by just leaving the lights on, basically.
Yeah, but it's
Yeah, it's something to
we
remember.
do leave the lights on so deep into the day, and you know.
But the other thing is that, and the door was open,
Yeah.
and it really should be closed because you want the vapor to go outside,
Okay.
rather than back in.
Okay.
So that's the bathroom. Your drying clothes internally, which you just need to have a dehumidifier if you dry clothes
Okay.
internally. Your mother-in-law has a dehumidifier, but it's not powerful enough. It's a 12 litre. You need
Yeah.
to have a 20 litre, and I would say, property like this, you probably need to have 2 dehumidifiers running.
Okay.
At least one constantly and the other one sort of as and when needed.
Yeah.
So surface relative humidity is a function of both the amount of vapor in air, which you can use dew point as a way of establishing that, but it's also temperature.
Okay.
Where you're getting the mold in the upstairs bedroom and downstairs, it's where you got cold temperature. So the 3 or 4 different influences. So one of them in the loft, you know how you're getting like zones where there's mold.
Yeah.
That corresponds exactly to where the zones where there's insulation from the loft
It's
is
gone.
missing.
Okay. So
And it's
I suspected that might be the case. I just
Yeah.
wanted to validate that before I start getting some,
Yeah.
because I've asked people to come over.
yeah.
Everybody comes with a different price point, a different cause of what's going on, which is why I've come to you. You see where I'm coming from?
I've
And
got no skin in the game. in
Yeah,
terms of,
exactly. So why I've come to you is
Yeah.
I need to know what I need to do to
Yeah.
resolve
Yeah.
these
Well,
problems.
exactly. That's what we're doing. So I can move some of the loft insulation around, but you know the problem is that you can end up with a new place that's,
Yeah, sure.
So it's really beneficial to add another layer, and I believe in having as much loft insulation as you can get,
Sure.
but at least a double ply. So you're getting thick loft insulation in one direction and then across the other direction,
Sure.
and right into the eaves, and it can be
A big
tricky
difference.
getting in there.
Mm.
So that's number one. Number 2 is you've got, as part of the building's design, is you've got large lintels which will
Yeah.
almost certainly have metal in them, and the metal gets cold rapidly. Irrespective of any insulation in the cavity, it will get cold, and so you're getting mold around the top of the lintels.
Right.
But you're also getting mold into the zones where you can't get the easy transfer of heat from the radiator. So cupboard, as an example, or behind the curtains,
Mhm.
or the window reveals. All of those. So the 3, if you like, 3 zones where you're getting particular heat loss, which is where you're getting the mold in there. So the lack of insulation, the metal, and the poor airflow.
The prayer flow.
And
Okay.
So, but the primary solution
Yeah.
is to deal with the vapor management,
Okay.
and the data loggers will help you with that.
Okay.
And-
So where should I place the data logger?
Well, keep them where they are.
Okay.
I've already looked at the calibration, but let's look on your phone, and I'll get
Yeah.
you to send them to me now. And then if you can send me if you can follow three rules over the next 3 or 4 days, and then send me an update next weekend.
Okay.
We'll just see how that compares to
Sure.
and it's a whole team effort. So
Mhm.
the family need to be on board, clearly.
Yeah, but as you can, we're quite big. We're 7 of
Yeah.
us living
Yeah,
here. So
yeah.
so 4
There's
kids, 2
Challenges.
teenage boys,
Yeah,
and the boys.
our teenagers.
Consistently, we keep discussing about time spent in the shower and
Yeah.
turning the shower into a sauna practically. So it has an impact.
Well,
there.
so there are a few things that you can do with relative ease. So one of them is put a spring hinge in the door there, and so that naturally forces the door closed.
Sure.
So you don't have to think about that.
So both bathrooms
yeah.
keep the door closed.
So, essentially, everybody generates roughly 2 litres of water per person per day. And if it's not going out the window, then it will find its way onto the wall, which is what you're getting.
Well, we do open the windows. I mean, we open, especially the one in the middle there, but it just obviously
it's untargeted, and most of the mold is going to grow at night. You know, between like midnight and 6 in the morning.
Okay.
When no windows are open. Look, there are essentially 3 approaches, and you've got to find the right one for yourselves. But so the German approach is to just open all the windows for like half an hour. But the thing in central Germany anyway is it's very cold, and so the outside air doesn't have much vapor. So you remove the vapor relatively rapidly. But in the UK, where we have high humidity outside, actually you're sometimes replacing humid air with humid air. So it's harder to take that approach. You can use the continuous fan approach. So the different methods of that, but the one that I advocate and use myself is continuous bathroom extractor fan. So it's constantly on, and it just has a slow flow.
So this one is continuously on, which is why it's on the low thing. So.
Okay, but does it ramp up when it senses high humidity?
From what I've read, it should be ramping up.
Well, we can test it.
Yeah,
but,
sure.
And then the other one is a dehumidifier, and dehumidifier is the only thing that the International Space Station has.
So where should I put it?
Where 2 places. One where you're generating the vapor, so kitchen, and the other one is where you're getting the damp issue.
So I use a lot of these ones.
So we're looking at these chemical dehumidifiers, and compared to the 2 litres everyone's generating, there are 9 of you, is it? Oh no, 7 of you. 7,
yeah.
So 14 litres a day, and these probably collect, I don't know, 100 ml or maybe 200 ml. It's barely doing anything.
So we put them in the wardrobe.
They're okay with the wardrobes, but it's still not really dealing with the primary issue.
So the primary issue would be get some dehumidifiers. I'll get those stuff.
So the other thing to say is to try and reduce the vapor at source. So two simple ones to do, but there are some other ones. Is cook with tops and pots and pans.
Yeah.
And I'm going to ask you in the next few days to try and do that as much as possible, and use the extractor fan. There is a bit of airflow through there, suggesting that there's a bit of a leak in the system.
Okay, so it's internal. It's not. It doesn't go out.
Well, I was wondering where does it?
Because so when we're doing the extension and remodeling the kitchen, the problem we have is that I think the slats come this way.
Right. So you can't.
So that means they come straight into here. So the slats. So we needed something, because if we go that way, that's the garage, and then we could have conducted it out, but we can't do that, unfortunately.
I did wonder. Yeah. So in which case it looks great, but it doesn't do anything.
It's just
so
really
if you
fashion accessory. Really.
But if you try and cook with tops and pots and pans, you can turn the flame down, and you reduce the amount of vapor generated by about 80%. Okay. So roughly speaking, when you're having a meal, sort of probably about per day, 1 to 2 litres has been generated from here. The other one is drying clothes internally, and you want to put it into.
We've got those.
I know, but if you think of it, they're not actually taking water out. They're just
creating
they speed up the process of drying clothes, which is great from a drying clothes point of view, but terrible from a wool point of view. Every kilo of extra weight from wet clothing is an extra litre of water.
Maybe I should turn this room just turn this place into like a utility room. Put a dryer in there and then it extracts out.
I would definitely have a dryer. Have you got a dryer? No.
No, we don't have a dryer. But I mean, I've got space for a dryer.
Yeah.
I can use this room as a.
I would definitely do that, but in the just in like these 3 or 4 days, just to get used to everything, you could do one of maybe 3 or 4 things. One is you could put it in a room upstairs with the door closed and the window open, or a dehumidifier on. That's probably what I would do. You could put it in the bathroom with the extractor fan running and just drying in the bathroom. Obviously outside if we can do, but it's harder.
Yeah, in summer we did.
Outside, I know, but these problems are in winter related ones.
Okay.
Or indeed just not dry and just not wash during the next few days. But I'm sure the wife will have something to say about that.
When you've got young kids, it's
difficult. It's a challenge.
To do that. This probably wasn't done very well by the guys that did it. So what I just wanted to do is to make sure that I take the right steps. I mean, the outside I'm going to do over summer. Yeah. You know, where the renders will be.
So the things to know on the render. One is that the cracks are very thin, and you can use this in acrylic caulk, or the other thing is you need to use an impermeable paint because it's an impermeable render, so the water isn't getting through. So you need to use an impermeable paint. Otherwise, you can end up hiding a crack, and it still absorbs water, but
like
it's hidden.
you mean?
No. Dulux do an impermeable, and Zinza do, and just look on
Those
the
are the outside paint, outdoor paint.
Yeah, exterior paint, external masonry paint. The other thing is that you just got to be aware that render. The reason you get cracks is because of expansion contraction.
Sure.
And you can put in expansion gaps so that it forces the movement down into the crack.
Okay.
And then you just have to keep an eye on that and use a mastic in that gap just to allow for expansion contraction.
Okay.
That's the managing inevitable. So this is on the south side, is it? Is this where the sun's coming?
So the sun that's east. So that's south. Yes.
Yeah. So that means that you're going to get much more sun, and it's going to get warmer during the day and colder at night. So you get more expansion contraction.
Right. Okay. So that explains a lot.
It explains the cracking, but it doesn't particularly explain why you're getting the mold. You know, typically you're going to get mold more on the north side than the south side. But I wonder whether, so you've cracked open the windows now, but at night I don't suppose you have the windows open on this side.
Not really. No, not on this side. No.
Because you're obviously on with the road here. On the other side, maybe you open the windows
easier,
more.
Yeah. So the other side is easier, obviously, because it's quieter from the road noise. The road noise that's terrible, really.
No, not at all. I mean, you barely notice it, but it also means that you're not going to open the windows.
No, not
and that's the point I'm trying to make.
But we do have the vent.
No, they're as good as useless. You can see there's mold growing around the vent, which illustrates the point. If you've got no airflow outside, then you won't get the ventilation. It'll just.
So I was thinking about putting an extractor fan in there.
Yeah, you could do, but so you and blow air out. I mean, it would be a way of doing it, a quiet fan, I suppose. Yeah, that's a possibility, and it's within the cupboard, so it's going to draw the air. But I mean, the other thing to do is insulation in the cupboard, and I'll show you some insulation solutions.
That would be great. So those are the kind of things I would like from you. Is, some solutions to some of these problems. So now that I've got the loft stuff, because I noticed that especially this section, it probably needs loft insulation. Yeah. And I'm thinking about actually, just biting the bullet and just doing it.
You might as well max out on it insofar. I mean, a if you wanted to, it's something that's very easy for you to do. It's not a complex job. And B, compared to all the other insulation solutions, it's one of the least expensive for the greatest benefit.
Yeah. Okay.
Things that particularly interest me are, one, the relative humidity, and I work out the surface relative humidity from that. And I'll talk through that. But do you see the temperature is 19 degrees centigrade and nearly 20?
Yeah.
That wall is 14 degrees centigrade, which is close to the dew point. So that's the second thing I'm looking for.
Okay.
Yeah, and I can calculate the surface relative humidity is about 90% at the moment. And mold will grow where it goes above 85%. So that's why you're getting it. So it's a combination of excess vapor, and we'll talk about that in a sec, and temperature, and it's that combination. You should always deal with the excess vapor first, but then the temperature. The temperature is from insulation, airflow, and obviously heat from the radiators. So we'll just slightly amend these, but we don't. You can see actually they're more or less in line with each other, and they're not far off that. So now, just if you press the green numbers, you calibrated these already, haven't you?
Well, I just saw they were the same, and then I did not do any calibration, but they came in, and when I switched them on, I left them, and then they were fine. They matched each other, and I thought that should be okay. I don't have the tools to tell you.
No, but I'm just having a look at it, and it is pretty good. So mold spores are everywhere in the world.
Yeah.
But once they start germinating, you'll get much higher concentration of spores. So what you really need to spray down all the spores all the mold growth as it grows, to try and reduce this
The impact.
the concentration.
Okay.
And I would use HG anti-mold spray, but bleach is the active ingredient, but it has a foaming agent that keeps it on the wall for longer.
Okay.
So be careful not to spray onto clothing or textiles, the wallpaper, because it could bleach it a bit. So just be careful on that, but don't go wild. But yeah, I think that's a starting point. In terms of getting rid of the mold, and once you've brought the vapor levels down, it will stop growing. And so the dew point is a measure of the amount of vapor in air. It's also the temperature where condensation takes place at. So I'm going to put this outside for a bit, and we can talk to what the outside dew point is. But internally we've got a dew point of 12.5. But you've had the window open for a while, but I would say that your dew point was probably more like, well, when I arrived it was 13.7, and even then you'd had the window open for a bit. I reckon it was probably more like 14 or something.
It probably was a lot higher.
It'll say on the, well, it doesn't say the dew point on this, but it takes a bit of time. But we're going to put it, I'm going to put this outside. I'll do that now actually while that's doing its bit. It's telling me relative humidity and temperature. And I won't go through each one, but the humidity spiking at 87, but at that time the temperature was about 20. But so the dew point you can calculate very roughly in your head as for every 1 degree centigrade difference increases the relative humidity by about 5%. Dew point is where it's 100%. So where we if you take 8 from that, gives you 12, and that's the dew point. So 100% minus 60. I just round it. Divided by 5 is 8, and then that gets you to that. So that's how you work out dew point quite quickly. But it shows you the dew point anyway. So if you press the number again. And then the calculator sign top right, export sign top right, and export CSV, and then send it to myself, simon@dampsurveys.com. I opened up the fan to have a look, and it looks pretty clear. There's a little bit of ducting that's in the way down there, but it's relatively small. I've cleaned it up, and we'll just see if that improves it. So we'll test out the speed now. Takes a while. It's very quiet. I think there's a slight improvement, but not a huge amount. But it's good for background, and hopefully that boosts up when it senses vapor.
Done this, and then we bought this.
The dehumidifier's
this
improved
helps.
it,
It's improved it significantly.
but it's still slightly underpowered, I would say. But you know, but the thing is that obviously some are noisier than others, so but it's going in the right direction. You got to remember that all the water that goes into plants comes back out as vapor, so you know that does add. But
you want to get rid of plants?
you need to have plants, But so what I was going to say is that where you've got mould, you often have condensation at the base of the walls, and this is using a dampener. So it's getting it's condensing down at the base. So what happens is so condensation and mould you'll get in the same environments because of excess vapor and insufficient heat. And insufficient heat behind this radiator, this sofa is going to stop heat. The flow. Where's the radiator?
There's a radiator here, and there's that one there.
So it's getting very poor flow from the radiator, and it's not getting in behind the sofa. And gravity will draw water down, and a damp brick is a poor insulator, so that's why you tend to get dampness at the base of the wall. But if you were trying to sell the property now, you would almost certainly get a surveyor saying it's rising damp, which it isn't. Right. But because of the base of the wall, they'll just automatically say it's rising damp.
Okay, so it's more like damp.
It's condensation.
Condensation. Okay.
Give you a few tips to reduce the amount of vapor condensing at the base of the wall. And so you want to try and increase the flow of air from the radiator. At the moment it's essentially blocked in the corner, and you'll get a flow up, but it won't really get across. So a few simple things. One, move the sofa away from the wall. Second one is to flip the curtain so that it's sitting on top of the sofa, so that the air can flow in behind there. And likewise there. This is for like the 6 months before selling the place.
Sure.
And you'll probably want to sell it in the summertime if you could do. And then the other one is to just reduce the amount of things in particular.
Well, you cannot tell.
I'm not the first to.
You cannot tell. So.
But particularly bottles and heavy objects, because obviously they'll get colder and stay cold for longer.
Okay.
So they'll end up causing heat loss around it. It's a bit like the metal in the.
Sure.
So you're getting metal in the lintels. The other thing is these will tend to reduce the airflow. So you've got to think of vapor moves through diffusion like smoke, but heat moves through currents, and you don't get very good currents from the radiator. Actually, you've got a lot of challenges, and you've got mold because of those challenges. And what you choose to do for yourself long term, I'll say what I would do. But in the short term, I'm going to say remove the drying clothes, put it into a room with the door closed and the window open, or extract a fan if it's in the bathroom, something. Just for the 4 days, just to drive the vapor levels down.
Okay.
Number one. Number two, cook with tops on pots and pans, and that will reduce the amount of vapor coming from cooking. And three, close the bathroom doors, and for the bathroom upstairs where the fan is turning off and the light's off, leave the light on. And you can sort of leave it on permanently. But I would, longer term, what I would do is I would have the dryer there. I would have a spring hinge on the door. I would ideally put in a kitchen extractor fan that's ducted out, and I know that's a challenge, but you probably, when you come to sell the property, it'll probably be flagged as an issue, and you may end up having money taken off you at that point. So you're almost better to bite the bullet and get the benefit of it. So you could have a ducting that, so the garage goes up to here, presumably, does it? That's the external wall, is it?
Yeah, so there's the garage goes up to
this wall.
I believe so, yeah.
So what you could do is you could have a ducting across through there, and just find a way across. You know, it could be done quite neatly. Okay. So we have an extractor fan, and we often don't use it, and we just use a dehumidifier instead. So dehumidifier run 24/7, 20
You mean
litre.
like boxing an extractor?
But a dehumidifier will do the same job.
Yeah, because I had one before. I mean, if I take all these things out, you see there's a gap going out there.
Oh, so it could be put back in.
Potentially.
But as I say, a dehumidifier can do the same job, but a 20 litre dehumidifier. Your challenges are that you're there are quite a few of you, and each mouth, each person generates roughly 2 litres per person per day. Secondly, you will find it difficult to open the windows on the front. So there's a lot to be said for running a dehumidifier in the rooms before going to bed at night, or just keeping them going. But if you don't like the noise, just run them before and after, plus open the windows first thing in the morning, and monitor it, and then deal with the insulation, anti-mold sprays, and then consider internal insulation. I'll show you some now. I think your idea of putting a continuous flow extractor fan in the into the cupboard is a good one.
Okay.
But insulation, I'll show you different types of insulation now. Different types of insulation. So this is PIR, which is suitable for a property that doesn't have a suspended timber floor, which you don't. It's polyurethane. Celotex is a brand name for it. It's relatively cheap. You can have almost any size, and you can put plasterboard on it. So that's good. This costs about 10 times the amount of that. This is called Space Therm. It's breathable, so it's better for older properties where you need breathability. This is very inexpensive. This is wood fibre. It's used for underlay, but it's suitable for cupboards. Because it doesn't look great, you wouldn't necessarily use it on normal walls. This is Semtapat, which is a German brand. It's basically lining paper with rubberized insulation. I don't like it so much, but you can get what's called thermal lining paper, and that's perhaps what I'd use in your property. And it's a thin layer with this sort of type of fibre.
So these are for the walls, yeah?
Yeah, I would do it. I would use it. Yeah. I mean, as much as anything else, you're never going to get those walls looking great, especially with the lintel where the plaster is blown.
Yep.
So putting lining paper is going to go a long way to solving that, and it will give it that extra. It will give it another 2 or 3 degrees centigrade, which would be enough to take it from being a mold risk to normal.
Sure.
Yeah, look up the extractor fan and see if you can increase the speed.
I can increase the speed of both of them. I should be able to. The thing is, that one has to have is meant to have like a humidity
sensor.
Humidity sensor.
Yeah, but
which should then boost it up to 15.
But that's a relative humidity sensor, and it may be that you still have high dew points and surface relative humidity, but not necessarily the air. So if you notice, the air in the centre of the room was 60% relative humidity, but the surface was 90% relative humidity.
But just to recap, is I'm taking away, get a dehumidifier.
Yeah, so brands are Miyako, 20 litres, Miyako compressor type or DeLonghi. They're all pretty good actually. I've tested them all out and they're not.
And they're for this room and upstairs.
Do you use Which at all? Do you know who I mean by Which?
Yes.
They're a
The
trade
comparison.
they're quite good for looking up stuff.
Okay.
But I've tested lots of different ones and I don't see a huge difference.
Sure.
Insulation, I showed you different ones for the wall, but for the loft just get standard
loft insulation.
North is quite a good brand, NAUFF I think it is.
Okay. And then for the walls, because I have to redecorate that. That's the
well, I mean, so if you use HG anti-mold spray initially, you'll find that you'll lighten the colour dramatically.
Yeah. So
I would personally trial it by sanding it, and then, I mean, that's probably a summer job. It's not an
no. So this is the plan for summer. Yeah. So it's starting now. Yeah. If you don't plan, it's never going to happen. So
but I would personally take the curtain rail down and use an insulation. I'd use lining, thermal lining paper.
Okay, that's probably the best solution.
I mean, that's the least expensive one. I mean, if you want to go to the next level. I mean, there is something. So I've insulated my house a lot.
Would you like a drink?
No, I'm good. And I've used.
I haven't had coffee today, so I'm getting.
I sometimes use a hybrid of the Celotex, which is the PIR, which is thicker, but around the windows you don't want it to be too thick because you lose visibility. It just looks a bit odd, and you can use the space therm in around there. So I've got that on there. The benefit of the insulation is also keeping the sound down, but obviously a lot of the sound will come through windows rather than the walls. But there is more than one benefit.
We don't have a problem with sound.
I know, but I'm just saying that it does have a dual
benefit.
So we're looking at the outside. The dew point is 5.4, and the temperature is 9.5.